A pharmaceutical manufacturer in Germany ran an automated oral solid dosage line. Stainless steel IBCs delivered bulk powder and granulate from the floor below. The process equipment that needed them sat on the floor above. Between the two floors, a dozen docking stations. And one fixed problem. The building shell was already designed before this interface was. The ceiling penetrations were fixed. The aperture size was fixed. The IBC could not be carried up to the machine. It had to be delivered below the station. So the valve itself had to travel down to meet it. Product had to cross a GMP floor slab without opening to either room. And the IBC didn't arrive by hand. Automated guided vehicles, AGVs, positioned them cycle after cycle for the life of the line. No operator corrected the alignment. The interface had to absorb it every cycle. Andocksysteme entered the project at scope definition, 10 months before the purchase order arrived. The ceiling apertures and the IBC handling concept were already set by others. The task was not to design the valve. It was to engineer an interface that could work inside constraints it never controlled. The answer was a split butterfly valve, an ASBV DN250 that traveled to the IBC. The active half hung on a lifting frame. A multi-stage telescopic cylinder drove it down more than 2 meters of stroke until it reached the passive half on the IBC. Containment traveled with it. A flexible spiral hose reinforced with a metal spiral replaced the standard bellows. It compressed 5:1, following the valve's full stroke. The contained zone ran unbroken from the production room down to the active valve face. Both valve halves stayed closed through the connection and separation. The powder path never opened into either room. Containment held across a building boundary, not just across a flange. Because the active half traveled and the passive half rode on the IBC, the AGVs only needed to deliver the IBC to a docking window, not to a millimeter. Andocksysteme designed the cleaning cycle with the transfer itself. A hose change, evacuation through a filter port, a cleaning rack collected by an AGV. Acceptance came about 10 months after the purchase order. Closeout followed some 6 weeks later. A highly automated plant still comes down to one interface. The ASBV split-butterfly-valve is what holds containment, while the geometry moves underneath it. The same passive valve was still the reference part in the customer's inquiry 6 years later. The earlier the interface enters a plant project, the less of the building it has to work around. Thank you very much for taking the time and watching this video. Feel free to talk to Andocksysteme right during the early stages of your next plant design. My name is Tim Rückert and we see us in the next one. Bye bye, see you soon.